Hey, let's head into arrays. Chapter 8. This is really a pivotal moment in the course. This is super important. In fact, if you notice, I'm going to cover arrays over 2 weeks. That way you'll have a lot of time to absorb how important arrays are. So why are arrays so important? I want you to realize at this point, let's say we had a variable called a. It's going to hold an integer. But a can only hold one value, like 37 or 1024. That's all it can hold. But let's say we need a variable to go through a lot of values. I don't want to have a variable for every value. An example would be the IRS at the United States government. Can you imagine if they had to have a variable name for every adult or working person in the whole US? Wow, there's 330 million people, figure 200 and so million are working. I don't want 200 million variables. So I want to use one variable that holds everyone and maybe break it up so that I could refer to a certain person here or a certain person there. And then I need another variable for how much money they made and how much taxes they paid. So arrays are really going to come in handy with larger values. So we're going to declare an array, we're going to initialize it and give it values. We're going to find out a little more about variable subscripts, and what we learned last week is going to be really helpful here, because what we learned in strings kind of helps prepare us for arrays. And then next week we'll get more into parallel arrays and passing arrays to methods. So what is an array? It's a variable. Think of it as a super variable that can hold lots of values at the same time. And the values that it holds, we call those items elements. So the elements or values in the array. Again, they could be every US person in the IRS array. And all the data items have to have the same type. So they all have to be strings, or they all have to be integers, or they all have to be doubles. And when you declare an array variable, it's pretty much the same. We give it a data type. We tell it that it's going to be a double. Think of this as the word array. I usually just say double array called sales figure. This is going to hold lots and lots of sales figures that are doubles. Int array for ID numbers. So a lot of integers that represent the ID numbers. So we're still going to need to reserve memory space. So before we declare an array, we tell the computer, well, how big is that array going to be? Look at this one. We're going to have a sale that's going to be a new double array that holds 20 elements. Or, by the way, both of these work. There's just different ways of doing it. This is in a double array named sale, and it's holding 20 elements. So either way works. The integer that's contained within these square brackets indicates how big it is, how many elements. So if we were doing the IRS, we'd need, 200 million, we said, of working people. And you want to be very careful that the array is big enough or not too small to hold all the values. So if you ever get something like out of bounds error, you know that you have gone past the size of your array. So let me give you an example. In our Java class, let's say we have 20 people. Now, if I make an array for 20, but then 2 more people add the first week of classes, I'm going to go out of bounds because I don't have the reserved room in memory. So I thought I would draw it out to help you see it. So let's say in a program, we're going to list some double numbers. I'm just going to call them my list. It could be all the jobs I've had and how much I made per hour or per year or something, a list of my salary numbers. So these are all doubles, and I must have worked just 10 jobs. And so it's reserving an array called my list. It's every value in this array needs to be a double, and I have room for 10 elements. And you say, well, how big can arrays get? How big can your computer handle? And that's an important piece. And that's why when we have big amounts of data like the IRS, they have major server farms to handle and hold their arrays, if you would. So when I do this, here's what happens physically in the memory of the computer. It draws 10 boxes, an array length in this case is 10, and it numbers the array. So think of this as mylist sub 0. That's its first index. So let's say I put in the number, my first job that I ever worked, I'm old. I made minimum wage at the time was $2 and I think 85 cents. So that was my first job. So I could put 285 in my list sub 0. And then the next value, my second job, I didn't make much more. I think I made, then minimum wage went up to $3.35 an hour. Yeah. So $3.35 an hour I could put there in, and I would say this, my list sub 1, that's the index number. So this is how my list can hold more than one item. It creates an entire array, not for each digit, but for each complete value. So 285, 335. I think my first teaching job, I worked at a high school in Bedford County a long time ago. I think I made $17,000 a year. It was a little tough. So with the family. So I could put these amounts right here, but after I get to my list sub 9, that's my 10th element, or at index 9 in this case, and that would have to be my present salary. Got it? So this is an array of 10 elements. Now, sometimes you're just creating a blank array so that you can fill it with input of the user. You may say, hey, how much did you make in your first job, second job, third job, fourth job? Or maybe look at the second example down here, everyone. Maybe I already know what's going to be in my array. Maybe I'm going to have the numbers 1, 2, 3, 4, 10, 11, 12. And do you notice I didn't tell it how many values to create? If you're going to assign a literal array here where we actually know the literal values, the computer can count and go, okay, you've got 1, 2, 3, 4, 5, 6, 7. Let's make an array with 7 values. The index will be from 0 to 6, and I'll go ahead and plug these numbers in. I don't have to tell it the size of the array like we did up here in braces because I'm assigning values right now. But if we didn't know how many values they're going to be, then I do tell the value inside the square brackets so I know how big my array is going to be. Now, we just call this is the elements of the array and the index, another term, and I want you to know both because it's up to who you're working with in code, which term they'll use. They also may call these index subscripts, and we use that terminology back in the last chapter with strings. So the integer contained within the square brackets is your subscript or your size or what index number you're on. And it indicates one of the array's variables or elements. A subscript that is too small or too large for an array is considered out of bounds, we said. So let me show you this example where I'm underlining on the screen. We can actually identify each element of the array one by one if we wanted to. So we could say sale sub 0 is equal to 2100. So the very first box of my array called sale that I've already declared previously, I could put in the 2100. So you can identify one element this way. And if you do create an array of, let's say, 20 elements, the subscripts would always go from 0 through 19, just like they did in the last chapter. So if I were creating sales figures 0 through 19, I'm skipping some in between, it would create this. So this is stated sales figures sub 0. The 0 could be called an index or a subscript. Sales figures sub 1. And in each of these boxes, because we said over here with the decimals, I can already tell these are going to be doubles. So I can put, for example, 2100 in this particular element. So let's take a look at a first program with arrays. And again, there's many ways you can make an array. Let's look at this way. So we have a program that is declaring an array. There are going to be two arrays. Line 5 is creating an array called codes with 5 elements, index subscript. This in line 6, you're declaring an array called sales. It's a double. It's going to hold double elements, and it has 10. So I've kind of taken codes and sales. Here's codes. So I've drawn an array from 0 to 4 that can hold 5 integer values right here in these boxes. And I've taken double sales and made the array from 0 to 9. So in the computer's head, we've kind of called ahead to make a reservation. I always think of arrays is if you didn't have many people making a reservation, you probably don't need a system. But if you have a lot of people making a reservation for this weekend to eat out, well, then you need some way of storing all of that, maybe using Open Table or using TripAdvisor or something. So that way you can make sure you have enough room in your restaurant. So this, we're calling ahead by declaring these two statements, making enough space for these 5 integers and these 10 doubles named codes and sales. So far, so good. Now on line 7, we're just going to declare one element at a time. We could have done this with an input statement and had them, type in the values, or we could do it like this, or we could use the single statement like we showed you earlier that had the curly braces on it to declare multiple values at the same time. Let's go ahead and fill this in. It says codes sub 0. In other words, the first element of the array is signed to 23, and that's an integer, so that'll work. So we're going to come over here and type in 23, and now it's starting to fill out the array. Next, code sum 1 in line 8 is set to 45. Let's come over here and put in 45. Oh, they're not going to fill out any more codes. Well, maybe later it'll do that. Okay. Now we're going to come to sales sub 0 and fill in 34.99. I might have trouble getting that in here because I've got things on top of it, but right here is 34.99. And sales sub 9, okay, right over here is going to be 88.33. And those are doubles, so all is well. And now in line 11, it said some codes are code 0 plus codes 1. So what would print here? Let's go ahead and see. Code 0 and 1, or let's go back here. Codes 0 or 23, code 1 is 45. So now when we run this little statement, it says some codes are 23 and 45. Good. And look at line 12. System.println some sales are sales 0, 34.99. And sales 9, 88.33. Just showing you what's in memory. Now in this program, if I were to do a sales sub 10. Now we got a problem with this. Let's go look over here. Is there a sales sub 10? Remember when we created this double array of 10 elements, it goes 0 to 9, and there's no index or subscript called 10. So if I try to give it the value of 77.1 and put a semicolon here, let's see how this rolls. When I go to hit run right here, notice, we got a problem. Let's read it. So when you see these errors, you'll know what's wrong. Exception in the thread of main, so we got a problem in main, and we have an array index that's out of bounds, and that's an exception. Every time you see the word exception in Java, think error, and it's telling you it's on, let's see, line 11. If you haven't figured this out yet, this is what it's trying to tell you. Line 11 is a problem, and there is the problem. So we can't go past the array. And I can't use a negative value here either. There's no negative indices or Java, and it tells you the same problem. I can't, out of bounds. So make sure you keep your arrays in bounds. Now, instead of initializing an array element by element like we did in the program we just finished, we're now going to use a keyword new to define the whole array. And then, just so you know, if you don't put elements in the array yet, it has a default value. Numeric array elements are assigned to 0. So in other words, if you haven't put a number in yet, it's going to be 0. Char and object arrays are assigned null. No surprise there. And Boolean arrays are assigned false. So if you're filling the elements and you haven't filled certain spots, this is the value that will show up so far. So let's go look at this code snippet right here. So we're going to do almost the same thing. Notice lines 7 and 8 looks just like the last program. We're going to say some code 0 and 1, sales 0 and 9. But look how I initialized the array this time. This is initializing the array with literal values. And it doesn't need a number in the square braces because the computer is pretty smart. It goes 0, 1, 2, 3, 4. Okay, I'm going to have an array that has 5 elements numbered from 0 to 4. So this is going to go in index sub 0 or subscript sub 0, sub 1, sub 2, sub 3, sub 4. So it's creating that array for you. And look at line 6. We're creating another array called sales, new double 10. But, well, we're not going to put any values in yet. So think in your head, what values are going to be there? Well, let's take a look. With what we just said about how an array initializes, when we go to run it, it'll say codes sub 0 is 24. Okay. Code sub 1 is 36, so that's how we got 24 and 36 down here. But since we didn't assign any values right here, it's just going to show 0 and 0. And if I would have made this array a Boolean, so let's change it up, new Boolean, and not given it any values, let's see what happens here. I'll go to run it again, and oh look, false, false. Pretty cool. And how about if I try to print codes sub 5? Now let's think that through. Is there a code sub 5? Sub 0, sub 1, sub 2, sub 3, sub 4. I don't have a code sub 5, so what will happen here? So when we go to run it, do you see it goes, I'm out of bounds. Now this might confuse you because you're like, well, I thought if we haven't put a value in, it's a 0 for a number. Yeah, that's if I've reserved a place in memory like this. But if I give it literal values, it didn't make it more than 5 elements. It stopped at sub 4. So if I refer to anything bigger than code sub 4, it gives me an out of bounds exception. And here we go. It tells me line 7 is the problem. So kind of interesting. Now you're starting to see how these arrays are getting set up. Let's talk about populating an array. Populating just means putting numbers inside the different elements in memory. So let's say we have an array called score array. It is an integer. I'm declaring it here. I'm going to tell it has 6 elements. So this is only going to have from 0 to 5. So ignore 6, 7, and 8 this time. So we're going to fill up 0 through 5. Now, we can assign literal values and populate the array. We could have the user input numbers to populate the array. Or we could even use a loop to populate the array. Let's look at this quick little for loop right here. So we have a for statement. It says we're going to go from sub equals 0. So it's going to go from 0. And it's going to start with 0 right here. And now it's going to do score array sub 0. Okay, so this is this box it's referring to. And it's going to add 3 to score array. So the very first time, we're going to get the value of 3. So I can put that in there. There we go. It's super tiny. Let me make it bigger so you're not going to be blind by the end of this. Okay. So we've got the number in here of 3. And of course, since it did the increment, now sub is 1. It comes back around. Now sub is 1. It's now going to populate score array sub 1 right there. And we're going to add 3 more. So it was 3. So now we're going to put the number 6 in. So now it's got the number 6 in here. Let me make it bigger. You get the idea now. So we've got 3, 6. It's now going to come up and it's now sub 2. So it's still less than 5. So we're going to keep going around. Score array sub 2 is adding 3 more on. So now with the increment, we've got 9 in here. So do you see loops are very commonly used to populate arrays. So if we wanted to store all the even numbers, the first 100 of them, we could have a loop do that. And this is going to keep on going. Now sub 4. 4 is less than 5, so our 9 plus 3 is now up to 12. So let me put 12 in here. Now, interestingly, in this array, we're almost done because now when sub is 4, 4 is less than 5, we do go in one last time. Score array sub 4, we add 3 more, so we're now up to 15. But as it adds the 1 extra in this case, now it's 5. It cannot continue when sub is less than 5. So in this particular example, we did not fill in the 5th item, which is actually the last element of the array. So this loop probably should have been less than or equal to, or int sub 5 if we just wanted to fill those 5 boxes here, 3, 6, 9, 12, 15. So a loop is a real handy way. And think to yourself that this line score array sub could even be a input line where you're asking the user to type in whatever number of values, and the loop could just loop back around to ask the user over and over and over again. We'll pick up on the second part soon.